boy, that would be unethical on my part, right? I can't do anything that's going to increase aggressive behavior in kids. So I may not be able to ethically manipulate that with an experiment, whereas I may be able to observe it in a preschool recess. Any questions there about what a naturalistic observation is? Okay. This is the single subject design I alluded to a minute ago. That's why I have in the parentheses up there, n equals 1, details, details, details. So I get a lot of data on a single individual, gobs and gobs of data on a single person. In medicine, it's used to investigate rare, unusual, or extreme conditions that don't occur that frequently. Can be useful in clinical, neurological, and neuroscientific areas, again, because of the rareness of some of these conditions. Main limitation, we said, as with the testimonial, is it generalizable to the general population? When I make the shape of if you look at me and I make this curved shape, what do we call that shape of a curve that goes up in the middle and down at the tail and is pretty uniform? The what?
I'm telling myself I know this.
We call it either the bell-shaped curve or the normal curve. And that's basically how, for instance, intelligence. When we go out and give intelligence tests to thousands of people, what we find is the mean is right around 100 at the top of that bell-shaped curve. Now, we have some people who get scores of 140, and we have some people who get scores of 60. But they're not as frequent as the 100 is. They're out in what we call the tails of the curve. Okay? Now, what I'm interested in as a psychologist is what principles generally apply to most people. So I want my results of my study to be indicative or reflective of the general population. The problem when you do a case study and you're putting literally all of your eggs in one basket, I don't know where that single case falls in that normal curve. Are they right in the middle and therefore pretty representative of the general population, or are they out here in the tails of the distribution and not very representative? I have no way of knowing. Does that make sense? We want our subjects to be typical. You know, that was the warning I gave you at the beginning of class yesterday, not to generalize even your experiences to everybody else, because you may not be typical. Just by the mere fact that you're sitting where you're sitting makes you less typical. What do I mean by that in terms of the general population in our society? Just by sitting where you're sitting, what does that mean?
Are you referring to being attending college?
That's exactly what I'm
referring to. College?
No, just going to college at all. Okay? Only about 40% of people in our society go to college. So right off the bat, that puts you in the minority. So you're not typical in that sense. Okay? So be careful about generalizing from you who are a case study to everybody else. So it's limited in its generalizability of findings to the broader population, since there's no way of knowing how representative or typical this subject is. Okay? Any questions? Okay. Third observational technique are surveys. Now, these would be the self-report measures that we mentioned a minute ago. So they're designed to investigate opinions, behaviors, or characteristics of a particular group, usually done in self-report form. You fill out a questionnaire, you respond to a survey. Okay. Problems with it, we've already addressed this first one. Do people answer honestly? And the fact of the matter is, sometimes they don't. Sometimes they don't on purpose because they want to look a particular way. Sometimes, the second point there is that their memory sucks. Okay? So if I ask adults how their parents handled weaning them off of a bottle or the breast as a baby, they may have no idea about that. They may not remember that accurately. That was 20, 30 years ago. So again, how accurate is our long-term memory? And the answer is not very. One strategy is to ask the same question in different manners to assess the consistency or the reliability. In other words, are people being honest? So sometimes, one of the tests we give, a personality test, is called the MMPI, the Minnesota Multiphasic Personality Inventory. And it's like 566 questions. Okay. Now, sometimes people say, "Oh shit, I'm not going to take the time to read 560." So they just go through and they randomly answer questions. Well, one way we can check that is there are about 17 questions on the MMPI that are repeated throughout the test. And that's a way of seeing whether they were answering consistently. Okay. And this is something we found out from the last presidential election. Computer surveys may elicit more honesty than face-to-face questionnaires. And what we think happened, to some degree, is some people didn't want to admit that they were going to vote for Donald Trump. But if you let them fill out a computer survey and they weren't answering this directly to somebody, they were more honest. And we find that more often the computer surveys showed Trump being more competitive or maybe even in the lead than the face-to-face, over-the-phone survey. Okay? Again, people are weird. We behave
Even with
differently.
the computer survey, then they figure their specific copy of the survey isn't going to get directly looked at or associated with them or whatever.
Again, computer surveys, sometimes more honest. Okay, important terms in the survey design. Okay, who is your sample, your group of subjects? That's a selected segment of the population used, hopefully, to represent the group that's being studied. In other words, going back to my study about depression, when I work with a sample of U of E students who say they're depressed, what I really want is to be able to generalize from that sample of depressed U of E students to the general population of people with depression in our society. That's who I'm ultimately interested in. So how confidently can I generalize from my sample of depressed U of E students to the general population? One problem I would have there right off the bat, as you mentioned a couple of minutes ago, you guys are in college. And most people who are depressed in our society are not college students or not college educated. That's a potential problem. Okay? A representative sample. Okay, I want my sample to be close, very closely parallel on relevant statistics to the larger population that I'm studying. Okay? Now, sometimes we get our sample through random sampling in the last column here. I would say sometimes we do that, but rarely, because what random sampling implies, and you see here in the description, process in which subjects are selected randomly from that general population such that every member of that random population, of that general population, has an equal chance of being included in the study. So for me to use random sampling in my depression study, I would theoretically have to have access to all the depressed people in the country, and I don't have that. So rarely do we use random sampling then.
I mean, plus, depending on the way someone gets people randomly, that might not be truly random.
True. What would be an example of of selection method that's truly random? So where everybody in the group has an equal chance of being selected.
If the group is all people in a given city, just pick someone, just go with the phone book, pick someone from there.
Could be, is everybody
Wait a
listed in the phone book?
second. Oh,
Yeah.
wait a second.
Could we like go to like a carnival and pick people out to do something?
Well, those are all the people who chose to go to the carnival. You see the
Census
problem
data?
here.
There's
What?
no way.
Census data, maybe?
What did you say? What? Anybody suggest? How about just putting everybody's name in a hat and pulling names out of a hat? Or putting everybody's name in a computer hat and asking the computer to randomly select subjects out of it. Anything that doesn't have some kind of systematic bias in it, okay? So again, it can be named out of a hat, or random selection by a computer. But to go back to your point about the phone book, or your point about the carnival, it's got to be everybody in my group has to have an equal chance. It can't just be people who chose to go to the carnival, people who have a landline and are listed in a phone book. And that's a problem. That's a problem. And that's why we rarely do random sampling. What we are much more likely to do is something called random selection. So like in my study, okay, let me describe to you a study that I could do. Because it would be a true experiment. This will be the next group that we can talk about. Let's say I have the hypothesis that making students take an exam in an uncomfortably warm environment is going to adversely affect their test performance. Okay? Reasonable hypothesis? Okay. So, the variable that I'm going to manipulate in that study, we haven't talked about manipulation variables yet, but we'll talk about it in a minute, is temperature in the room that you take the test. So let's say I said, okay, on test, let's say I had 20 students in this class. And I say, okay, on test day, 10 of you are going to come down the hall with me to the sauna room and take the test in 95-degree heat. The other 10 are going to be my, what do we call the normal group? Control group. 10 of you are going to be my control group. You're going to take it in a 75-degree classroom. Okay? So those are my two experimental groups. So I give the test, and sure enough, I find out that one group tested better than the other group. What if so how did you choose your 10 out of the 20 for each group? Let's say I had said, okay, let's say I had 4 rows of 5 students in a row. There were 20 students. 4 rows of 5 students. And I had 10 students in the back 2 rows, 10 students in the front 2 rows. What if I said, okay, you 10 in the back are going to be in my sauna group, you 10 in the front are going to be in my control group? Is there a problem with that?
See, what I think is that stuff mentioned earlier, end with this, that you're introducing extra variables.
Like what?
Like, say, a different room, they're in a different room regardless of the
That's
temperature.
true, okay, that's another issue.
And
But what
that
about,
one, they sit in different places in the classroom, which might have its own correlation.
exactly, is there anything different about students who gravitate towards the back of the class versus students who sit in the front of the class? I don't want to cast any aspersions on you guys who choose the back of the class, but it's just possible that you're not as motivated, you're not as interested in the topic, whatever. And the people in the front are more interested, maybe more intelligent. I don't know. But as a researcher, I can't handle that I don't know. So I can't ever let the subjects choose which group they're going to be in. I, the experimenter, have to be the one who always assigns my subjects to my group. And what I would do in that case is random assignment of the 20 subjects, the 20 students in my group. So I would randomly pick your names out of the hat. I would go down my class roster. Every other person would be sauna group, control group, sauna group. Anything that didn't systematically bias who is in what group. Did everybody see that? You got to randomly assign your subject. This will be mentioned on a later slide. Okay. I kind of I may refer to this on a later slide as random selection being the penicillin of research, because you think of penicillin is getting rid of bacteria and germs. Okay. Well, you guys are messy because you have different intelligence levels, different study skills, different levels of motivation, different interest in the topic, different pre-existing knowledge about psychology. You know, you're all over the park. What do I do with that mess that you guys bring to me in a study? Well, I randomly distribute it across my groups. Okay, I take it and I spread it randomly. There's no systematic selection of brighter people here, more motivated people there, etc. Okay? They see that. So, the fourth descriptive method we're going to talk about is the correlational study. The correlational study here is a study that allows the precise calculation of how strongly related, here you see the related in co-relational study, how strongly related these variables are to each other. So an example would be, when you guys apply to college, one of the pieces of data we ask from you is, what was your GPA in high school? Why do we do that? Why are we interested in your high school GPA?
That would tend to relate to how well you're going to do.
Exactly, because we know from correlational studies that high school GPA has a moderately positive correlation to college GPA. Because we want to make good decisions about who we accept into college. We don't want to accept people who are not likely to be successful in college. We don't want to waste our time, and we don't want to waste your time and your money. So, we look for variables that are correlated, that have a relatively strong relationship. We statistically measure that correlation through a coefficient of correlation depicted by a small r. And that's a numerical indication of the magnitude, the size, the strength of the correlation, and the direction of the correlation between two variables. Okay, what about the size of a correlation? We know it's got to fall in the range of values between plus 1.00 and minus 1.00. So if you ever see a correlation greater than 1, you know somebody screwed up. It's not possible. Because a correlation of 1,
What would the graphical correlation of 1 look like?
it would be a straight line between my two variables.
So basically, something that's greater than 1 would be describing a line that is more straight than a straight line.
Exactly, which is not possible. Now, when I say a straight line, we think of an x-axis and a y-axis, okay?
Yeah.
Okay, the x-axis is your college GPA, and your y-axis is your high school GPA. If they were perfectly correlated, plus 1.00, that would mean I would have a straight line,
Yeah.
such that if I knew your high school GPA, I could exactly tell you what your college GPA is going to be. Is that the case?
No.
No. Why not?
Because maybe there's like a situation like a death or something that like throws you off.
Yeah. How hard did that person work in high school to get that GPA? How hard are they going to have to work in college to get that?
And situations that could throw off their game.
Right. Are they going to get to college and go crazy and go out drinking every weekend or night of the week and partying and staying up late and not being able to apply themselves? Or are they going to work real hard? I don't know. Okay. A difficulty of coursework. Is the difficulty of coursework in college going to be significantly different than the coursework in high school? Probably. How is that going to affect GPA? I don't know. We don't know. So we never have a perfect correlation in human beings between variables. So if I were to ask you, what aspect of the coefficient of correlation measures the strength or the magnitude of the relationship, your answer would be the second bullet point here, the absolute value between 0 and 1.00. That's the strength or the magnitude of the relationship. So for example, a correlation of 0.85 is a much stronger relationship than a correlation of 0.15. Okay? Nothing to do with the sign, the plus or the minus. Okay? The absolute value. So what does the sign mean? Anybody know? The plus or the minus? Okay?
It's which way the line goes, basically, like if it goes this way or this way.
Right. Is it, so if we have a plus 0.85, that means these two variables tend to move in the same direction. So if your high school GPA is higher, your college GPA is going to be higher. Okay? So the correlation between high school GPA and college GPA is a moderately high positive correlation, probably around 0.6 plus 0.6 or so. Okay? Now, if we have a minus sign there, that indicates that we have an inverse relationship between our variables, such that the higher one variable is, will lower the other variable is. So, do you think there is a positive or a negative correlation between the number of hours a week you spend playing video games and your GPA in school?
Or inverse.
Inverse, right. The more time you spend doing something other than studying or reading or homework, like playing video games, the lower your GPA is. It's probably not terribly high, but it's probably a negative correlation.
Well, unless you're an absolute genius, like, don't need study.
Exactly.
Well,
And there are some of
the
those.
correlation, I would think, would be for the general population.
Yeah.
Yeah,
And that
yeah,
person
exactly.
is someone who makes the correlation less inverse.
Exactly. Can anybody think of another negative correlation between two variables?
The amount of food you eat into your weight loss.
The amount of food you eat, more food you eat, and how much weight have you lost?
Yeah.
Exactly.
Yeah.
They would be opposite. what would be positive would be amount of food you eat and weight gain.
Yeah.
More food you eat. Everybody see them. So know those aspects of the coefficient of correlation. I'm never going to ask you to calculate. So here's a positive correlation, finding that two factors vary systematically in the same direction, increasing or decreasing together. Here I have IQ in grade 1 now. Positive correlation. Negative correlation, two factors vary systematically in opposite directions. One increases as the other decreases. For example, hours spent watching TV each week in grade 1. Okay? Any questions? Here's a study that was actually done that collected data on percentage of studies endorsing practice testing. This is in your textbook. That is, if you sit down before a test and do practice tests. And what you find here is that percentage, again, the more practice testing that is done, the higher the GPA.
That's weird. I find it interesting that the 0.7 to 0.1 and then the next one are, the first one's higher.
Actually lower, yeah. And again, sometimes you get that.
I just find that really
You get that.
interesting.
So it's not a real clear
Yeah.
kind of
Maybe
linear
some of those people
relationship.
that lower bracket support the practice testing because they need the help.
Yeah. Yeah, I was thinking like, since they're so low, they want to get better, but I guess the other, like, 2 like, I'll be okay. That's what I was thinking in my mind.
Again, yeah. Some people who have low GPAs think goofy. Okay, they think goofily. They don't, or they're not that motivated to do that. So, you know, they may not endorse the importance of practice. Who knows? Once they start getting maybe a little bit more serious about their grades, now you start seeing it being a more linear, direct relationship. Okay? Okay, what about the relationship between correlation and causality? There's data out there that shows eating curly fries or listening to Morgan Freeman is correlated with higher intelligence. Do you think eating curly fries or listening to Morgan Freeman causes people to be brighter? No.
I
And this
wish.
is the problem with correlational studies. We call it the third factor problem. When we do a correlation here, we're only looking at two factors. Okay? Now, is it possible one of those factors causes changes in the other? Yeah, it's possible. Let me give you a different example. Let's say I'm interested in the amount of violent TV content a child watches and how aggressive they are. So I go out and I collect how many hours a week they spend watching violent content on TV and how aggressive they are. And sure enough, we get a moderately positive correlation. Can I conclude that just on that correlational data, watching more violent content on TV causes kids to be more violent? Why can't I assume that?
Shouldn't assume it, but probably some people will anyway.
Some people will, but what could be another possible causal relationship between choosing to watch violent content and being more aggressive?
It'd be the other way around. The aggression causes the what.
Exactly.
Oh.
It could be that people who are already more aggressive like to watch violent content on television. So I don't know which direction the causality is, if there's causality. Now let me bring up the third variable problem. Do you think if a child lives in a home where there's domestic violence, one of the parents hitting the other parent, or there's a strong reliance on corporal punishment, hitting the kids, Do you think that could be related to violent behavior? Yes, we know that it can be. So there's a third variable we haven't even measured when we look at violent content on television and aggressive behavior. That's the third variable problem. So even if two factors are strongly correlated, a correlation does not necessarily indicate causality. You know, people who listen to Morgan Freeman happens to be, he does the voice overlays on a lot of kind of intellectual, National Geographic programs. So there, people who are more intelligent can watch more of those kind of National Geographic programs and therefore listen to Morgan Freeman. So there's the relationship between Morgan Freeman and intelligence. A correlation reveals only that two factors seem to be related or that they co-vary in a systematic way, and only experiments allow for establishing and making cause and effect statements. And that's going to be the next type of study we talk about. Okay? Any questions? Okay, an experiment, a true experiment. These are used to demonstrate, these get to the why of behavior, demonstrating a cause and effect relationship between two variables. Involves deliberately varying one factor, which is called the independent variable. In my sauna study, what was my independent variable? What did I manipulate to see if it had an effect on testing?
Temperature.
Temperature in the test setting was the independent variable. And then we measure the changes, if any, that the independent variable produces in the second factor, called the dependent variable. What was the dependent variable in my sauna study? What did I measure in my subject?
Grades.
Test results, test performance, exactly. So I want to see whether modifying the temperature under which you take the test influences your test performance. Now, studies may sometimes include unwanted, confounding, or extraneous variables which have to be controlled, like pre-existing knowledge of psychology, motivation to study the subject. And that's what I control by using random assignments.
Could cheating be one of them? Like,
Cheating could be, so I would have to closely monitor the test performance to make sure cheating wasn't involved. Exactly. That could be an extraneous or confounding variable. And it's possible that people who gravitate towards the back of the room are more likely to cheat. They want to hide. I don't know. It's just a possibility. Okay. This is a true experiment that looked at the effects of practice testing on retention. So 1 week after experimental sessions,